So in the previous section, we derived the expression for maximas and minimas logically in a nice and an intuitive manner. However, now I want to do it more formally using math. Okay, let's do this, guys. Let's just do it. So suppose I have the same two sources, S1 and S2, and these are waves. Could be electromagnetic waves, could be water waves, could be sound waves, it doesn't matter, but they are waves. And so each wave can be represented, let's say, as y1 is having some amplitude A, sine, something, what do we call it? Okay, we'll call it as omega 1 t. And let's say y2 is A sine omega 1t plus phi. What have I written over here? Okay, what I wrote is the following. See, these two are going to meet at some random point. So let's say at this point where they're meeting, let's say the first wave ends up having this particular equation. And since they are coherent, this will also end up having the same frequency, of course, but it will have some phase difference at this point. So this phi is the phase difference at the point at which they're going to meet. And let's not have the same amplitude. Let's say that this one has a different amplitude. So we'll take a much more general case. So what's going to be the resulting wave over there? So the resulting wave, I will call it as y, will be y1 plus y2, a superposition principle. So it is going to be the sum of the two. It's going to be A sine omega 1t. I don't know why I call it as omega 1. I might as well have called it as just omega. It's okay. Let's just stick to it now. Omega 1t plus phi. And now I have to do some trigonometry. What trigonometry can I use here? Oh yeah, I remember. Sine of A plus B is sine A cos B plus cos A sine B. Okay, so I can... So what will I do with this? What can I do with this is... Aha. Here I see some constant. I can see sine omega 1t is a constant. I just take it outside. So I get y is equal to, if I take sine omega 1t outside, sine omega 1t outside, I get a over here plus b cos phi. And over here, I have b sine phi into cos omega 1t. Okay, what do we do next? I don't see any further simplification that I can do here. What we can do over here is we can say, well, look, the resulting point over here must also be in the same format. It must also have some amplitude, and it should be written as sine of omega 1t plus some random constant. So this must be of the form y is equal to some random number, which is going to be the new amplitude. I just call it as r, into sine omega 1t plus some other phase difference. I don't know what's going to be the new phase difference, but it will have some phase difference compared to this original wave. Let's just call it as delta. That's the phase difference that the resulting wave is going to have with respect to y1. Okay, let me now expand this. Sine omega 1t into cos delta plus r cos omega 1t sine delta. And now I say, look, this is equation 1, this is equation 2, they have to be the same. If they have to be the same, then r cos delta must be this term. Yeah, they have to be equal. And over here, r sine delta must be equal to this term. So that is the condition that matches this, and using this condition I can calculate what r is and I can calculate what that delta is. So let's put down these conditions. So if 1 equals 2, then we have a plus b cos phi has to be equal to r sine omega 1 t. And I should have b sine phi equal to r this is not sine omega 1 delta t. This has to be cos delta. Oh, I'm sorry. I'm so sorry. So this has to be r sine delta. Okay. Now I'm on the right track. So from this, my aim is to calculate what r is and calculate what delta is. How can I do that? Well, that's easy. Square and add. If I do square and add, I get r. Because sine square and cos square, when I add them, I get 1. And if I divide them, I get delta. So first, I'm going to square and add. Square and add. So I have to now squeeze in things over here. Bear with me. So if I square and add, I get a plus b cos phi the whole squared, which is a squared plus b squared cos squared phi plus 2ab cos phi plus I have this squared, which is b squared sine squared phi, and this must be equal to r squared cos squared phi plus r squared sine squared phi. So that must be just equal to r squared. And so now we know what r is. So r is going to be the square root of a squared, and this is b squared plus 2ab cos phi, and that is the resulting amplitude that I'm going to get for the interference that happens over here. So what this tells me is that when the two waves have some random phase difference phi, the resulting amplitude is going to be this number. And now what is going to be the resulting delta? I have to do that on the other page, so let me do that. So the resulting delta, I'll keep it over here. These are the two equations which I have. These two equations. So I can now write that. Let me just write these two equations down. I have a plus b cos phi is equal to r cos delta, and I have b sine phi equals r sine delta. Okay, so now if I divide them, so I do this second equation, I divide by the first one, I get b sine phi divided by a plus b cos phi, and that gives me tan delta, and that tells me what is the phase of the resulting wave at this point. So let's look at these two values which I have. I have r, which is square root of a square plus b square plus 2ab cos phi. When is this going to be maximum? What is the maximum value for r? Well, the maximum value for r is when this right hand side is maximum. And now a and b are fixed, so the only way to maximize this is when cos phi is maximum. So r becomes r max when cos phi is maximum. And what's the maximum value of cos phi? That's 1. And when does that happen? Well, when phi equals 0. Or when phi equals 2n pi. Uh, 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 I got ahead of myself. Or phi equals 2 pi. Or 4 pi. Or 6 pi. Or in general, 2n pi. And guess what? We've gotten this result before. Here it is. Ta-da! Same thing, same thing, same thing. And now, if I ask you when is this number minima, as when this number is minimum, so that is when r goes to r minimum, and that is when cos phi is minimum. And what is the value of cos phi? Please don't say 0, it's minus 1. So this is minus 1. And when do we get a minus 1? When we get a pi, or when we have 3 pi, or 5 pi, or I can call this as 2n plus 1 pi. And this is for n equals 0. And we have gotten that as before as well. See? Same thing, right? So intuition also works. You don't have to always do things formally. Okay. All right. Let's look at what's going to be the resulting maxima. So R max is going to be the square root of a square plus b square plus 2ab. Cos phi is 1, remember, so it just becomes a plus b. That makes sense. When they have maximum value, the two just add up. And if the two had the same amplitude, it just becomes twice. That makes perfect sense. And over here, what is going to be the minimum value of the amplitude? Well, it's going to be a squared plus b squared, and cos phi is minus 1, so it gives me minus 2ab, and that is a minus b. Not surprising at all, because when they are two out of phase, that's 180 out of phase, then they try to eat each other up, and you get a minus b, and if a is equal to b, then yeah, they eat each other up completely and you get a 0. That's exactly what we saw in the previous cases, that I just assumed that their amplitudes are the same, and so you end up having a minima. I said I end up having 0 or whatever. Okay, so let's look at the intensity. Intensity of the maxima is always proportional to the square of the amplitude. So the intensity of the maxima is some random constant, let's call this proportional, to a plus b the whole squared. Okay, it's proportional to R max, and I minima is proportional to a minus b the whole squared. Therefore, if I compare the intensities, so I max is to I minima is a plus b the whole squared is to a minus b the whole squared. But guess what? I can also write this and say that this intensity is proportional to a is the amplitude of the first wave, which has to be proportional to the intensity square root of the intensity of the first one. And b is the amplitude, it has to be the square root of the intensity of the second one. So I can also call this as root of I1 plus I2 the whole squared. And over here I can say I minima has to be proportional to the square root of I1 minus square root of I2 the whole square. I hope you understand why I'm taking a square root, because remember, intensity goes as amplitude square, so the amplitude should be the square root of intensity. So I1 is the intensity of the first wave, I2 is the intensity of the second wave, and I max is the net intensity. So if I1 and I2 were equal, in the case where they were maximum, then you would, in the case where the amplitudes were equal, then you would see that the maximum intensity would be proportional to 2 root of I the whole square. It would be proportional to 4 times the intensity. And over here, it would be proportional to 0. So in the case where the two are exactly equal to each other, the maximum intensity becomes 4 times the individual intensity, and the minimum intensity becomes 0.